Alcoholic AOH is a dehydrohalogenation. So which means here you see the HCl and then water molecule gets eliminated in the presence of ethanol. On heating, we get acetylene formation. Okay. Then we'll move on to methylene chloride or else dichloromethane. It is prepared by the reduction of chloroform. So first we have to take chloroform in the presence of zinc along with this hydrochloric acid. The reduction reaction, we get the hydrogen that is attached over here, so that we are getting CH2, Cl2 with the HCl. So here one chlorine is removed and it is eliminated as HCl. Then reduction of chloroform using hydrogen along with the nickel. So chloroform with the nickel, we get a methylene chloride. Okay. Then chlorination of methane. Here in chlorination of methane, the methane that reacts with chlorine in the presence of H mu that is light, we get a methyl chloride formation. Okay. This on further treatment we get methylene chloride. Okay. Now comes uses. See here in uses it is used as a aerosol spray propellant. Then it is used as a solvent in paint remover. Okay. And also a process solvent in the manufacture of drugs and also a metal cleaning solvent. Then comes trihaloalkane. See here in trihaloalkane, we are replacing the hydrogen with the 3-chlorine so that we are getting chloroform and again iodoform. Okay, so chloroform is an important trihaloalkane. The most methods it is chloroform as it gives the formic acid on hydrolysis. Okay, so if you take this, it takes place by 3 steps. The first one is the oxidation, chlorination, and then hydrolysis. Here in oxidation, it reacts with the chlorine, that is alcohol, ethanol, that reacts with the chlorine to form acetaldehyde. And again, on further treatment with the chlorine, it forms trichloroacetaldehyde. This trichloroacetaldehyde, on treatment with the calcium hydroxide, form chloroform CHCl3. Right? So now comes physical properties and then chemical properties. Here in physical properties, chloroform is a colorless liquid with peculiar sickly smell and a burning taste. It has a burning taste, and also the vapors will make the nervous system to get unconscious if we inhale that vapors. Okay, so it is used as an anesthetic. Then chemical properties. First comes oxidation. So this chloroform on oxidation is in the presence of air, light, we get the product as phosgene. Then on reduction, it forms methylene chloride. On nitration, it forms nitro group, that is the chloropicrine, nitromethane, chloropicrin. It is used as an insecticide and also soil sterilizing agent. Then comes carbylamine reaction. Here in carbylamine reaction, methylamine on treatment with chloroform, we get methyl isocyanide. Okay. Now comes tetrahaloalkane. Here in tetrahaloalkane, it acts as a good example, that is the carbon tetrachloride. Now, in chlorination of methane along with this chlorine, in the presence of ethylene, it forms Cl4 with HCl, and then carbon disulfide reacts with chlorine to form Cl4 along with H2Cl2. Now comes physical properties. In physical properties, it is a colorless liquid with a specific smell, and also it is insoluble in water but soluble in organic solvents. Now comes the chemical properties. Here in chemical properties, you see carbon tetrachloride reacts with the hot water to form phosgene. So it is a poisonous gas. Now on reduction, it forms chloroform. Okay, the last comes freons, that is the chlorofluorocarbon. Here it is a chlorine and then fluorine derivative compound of methane, right? So here the freon is represented as freon CBA. The C refers to the number of carbon atom, B refers to the hydrogen atom, and A refers to the number of fluorine atoms. So here first C refers to the number of carbon. So here one carbon atom, one fluorine atom. So 1 minus 1 will be equal to 0. Okay, so like this you have to calculate. And then h plus 1 simply the value that we get along with that 1 should be added. See here we get as the value as 1. Now fluorine. Here 1 fluorine, 2 fluorine, 2 and here 3. So now freon 1 1. So their name will be given as like this. Freon 1 1, freon 1 2, freon 1 1 2. So the freon will be named as like this. A compound will be named as this manner. Okay. Now here you see this freon 1 1, freon 12. This will be prepared with the action of hydrogen fluoride on treatment with carbon tetrachloride in the presence of this catalytic antimony pentachloride. Antimony pentachloride. This reaction is said to be Scott's reaction. Here HCl and this CCl2F2. This is said to be freon 12. Now comes physical properties. See here, these freons are highly stable, unreactive, non-corrosive, non-toxic, and it is easily liquefiable. Yes. Okay. Now comes uses. See here, this freon is used as a refrigerant in refrigerator and also in air conditioner. Uh, so although it is having a high stability, non-corrosive, non-toxic agent, here it will generate a high amount of heat. It will liberate a heat that will act as a environment pollution. Okay. Now it is used as a propellant for aerosols and then foams, and also for shaving creams also this will be used. Then comes DDT. DDT is nothing but dichloro-diphenyl dichloroethane. Okay. It will act as a good insecticide, and that was prepared as a first chlorinated organic pesticide in the year 1873 and in 1939. Paul Muller and then was discovered this DDT as an insecticide, and also he awarded Nobel Prize in Medicine Physiology the year 1948 for this discovery. Here, this DDT is nothing but chloral on treatment with the chlorobenzene and the presence of corn sulfuric acid, we get the product as a DDT. So this compound will be used as a good insecticide, best insecticide. See here to kill insects, especially the disease which the insect which carries a diseases like malaria and then yellow fever. Then it is used as a forms to control some agricultural pests, including construction as a pest control. And also to kill various insects like housefly, mosquitoes also this will be used.